Copolymers are everywhere you look. They are in medical devices and common toys. Most of you will probably use them sometime in your career, especially since they usually have better properties than their homopolymers. Copolymers are chains of two or more different monomers that can be arranged in three different ways: alternating, block, or random. There are other types of copolymers, including all of the branched copolymers, but we will not be going over those today. Let's start with random copolymers. These copolymers consist of two or more monomers in a chain with no kind of structure or pattern. The name random is very fitting. As you can see in the top right-hand corner, there is not pattern in the red and black dots on the chain. This is a perfect example. Because of this lack of structure, random copolymers tend to be less crystalline, since crystallinity is measured by uniformity. This gives them amorphous properties, including, but not limited to, lower melting points and specific gravity, lower glass transition temperatures, increased mobility, a higher impact strength than their homopolymers. These properties are not guaranteed, but they tend to be present. Alternating copolymers are very different in structure. They have a strict pattern in which they alternate between monomers. This means that no red dots are touching red dots and no black dots are touching black dots in the photo to the right. Even though they are structurally different, many types of alternating polymers have similar degradation temperatures to random copolymers. However, they tend to be more crystalline than the random copolymers due to their structure. One big thing that causes this difference is how they are created, but we will go over that later. Block copolymers are the final type of linear copolymer that we will go over. It consists of large strands or blocks of different polymers chemically attached to each other. This creates a copolymer structure similar to the picture above. As you can see, there are alternating groups of red and black present in this chain. These chunks of similar monomers is the major structural difference between this copolymer and alternating copolymers. One awesome thing about block copolymers is the products they have made possible. One product in particular is a copolymer with high elasticity that is comparable to rubber, and it is thermoplastic, making it recyclable and better for some applications than actual rubber. The process that makes each of these copolymers different from polymers and each other is called copolymerization. This is the process of polymerizing two different monomers simultaneously with the goal of incorporating both of the structures into a single polymer chain. It sounds similar to polymerization, but it is different because it uses two or more monomers, whereas polymerization uses an element or free radical to break the bond in a monomer and have it reach out and react with monomers of the same composition. One popular kind of copolymerization in particular that is oftentimes used to make random copolymers is one-pot copolymerization. This just means that as one material is polymerizing, another material is poured into it and reacted with an excess of one material. This adding of a second material can be random or it can be very strategic to give scientists the expected or wanted outcome. There are other types of copolymerization too. For example, alternating copolymers are created using two monomers that prefer to react with others rather than themselves. This makes it to where the bonds are between monomers of different kinds rather than having clumps of similar monomers, creating a pattern. Block copolymers are less about what monomers are used to create and more about how they are created. Block copolymers are often created using sequential monomer addition. This is exactly how it sounds. Polymers are reacted in a sequence to create blocks. Specifically, one monomer is reacted into a polymer. Then another monomer is added and reacted to the end of that one. These different processes create all different types of copolymers, giving manufacturers many different products to choose from, and bringing you better and stronger items.